This is our second to last section in chapter 2, 2.5, solving compound inequalities. What do you think of when you hear the word compound? Combined, like a compound word would be how many words combined? 2, right? Compound word has 2 words that are combined together. Same thing with a compound inequality. It's 2 inequalities that are put together. Okay? So there's a lot going on here. We'll spend a little bit of time on this slide right here. A compound inequality is an inequality formed by joining 2 inequalities with the word and or the word or. So those are the only 2 words that we use to combine compound inequalities, and or. So the left column over here talks about and compound inequalities. The graph of a compound inequality with and is what we call the intersection. That's the mathematical term for it, of the graphs of the inequalities. The graph shows numbers that are solutions of both inequalities. So for a number, you might want to listen to this, pay attention to this part that I'm about to say. For a number to be a solution for an and compound inequality, it must be true for both inequalities. Does that make sense? So down here we have 2 is less than or equal to x, and x is less than 5. For a number to be a solution of this, it must be true for both inequalities. Does that make sense? So, how we graph an and compound inequality, just like it says, it's the intersection of the 2 graphs together. So I want to find the shaded region that makes both inequalities true. So if I have x is greater than or equal to 2, that's just a normal inequality we've been dealing with the past few weeks, right? Got a closed circle at 2, shaded to the right. Does everyone agree that's how you would graph x is greater than or equal to 2? Okay, and the second part of this and compound inequality is x is less than 5. We'd have an open circle on 5, shaded to the left. Does everyone agree with that? Okay. For an and compound inequality, we want the intersection of those 2 graphs. So where the shaded region is the same. Well, the shaded region is the same, greater than 2, and less than 5, so that's just between my 2 points. Does everyone see that? That's where the 2 shaded regions are the same. It's just this area right here. Does everyone see that? X is greater than or equal to 2 is shaded to the right. X is less than 5 is shaded to the left. If I stack those 2 graphs on top of each other, the shaded region where they're the same is right between those 2 points. So, this is the actual graph of our and compound inequality. There's no arrows or anything because the shaded region was not the same outside of this point, was it? Because there's no shading for x is greater than or less or equal to 2 out here, is there? There's no shading outside of this point because there's no shaded region for x is less than 5. Does everyone see that? I know that's a lot to take in, a little different than what we've been doing, but are there any questions about that? For and compound inequalities, we want the intersection of the 2 graphs, where the shaded regions are the same. Okay? Most of the time, not saying all the time, but most of the time, for and compound inequalities, your shaded region will just be between your 2 points. Okay? Any questions on that? Let's talk about or compound inequalities. The graph of a compound inequality with or is what we call the union of the 2 graphs of the inequalities. That's the mathematical term for it. We want the union of the 2 graphs. The graph shows numbers that are solutions of either inequality. So for or compound inequalities, for a number to be a solution, of this compound inequality. It just has to meet one of my conditions. It just has to be true for one of my inequalities. Over here, it had to be true for both. Over here, it just has to be true for one or the other. Does that make sense? So, once again, they're going to graph these two inequalities individually. So y is less than or equal to negative 2. Closed circle on negative 2, shaded to the left. Y is greater than 1. Open circle on 1, shaded to the right. Does everyone agree with those two graphs? When we graph an or compound inequality, we're just graphing the two graphs on the same graph. Okay? So we put y is less than or equal to 2 on the graph. We put y is greater than 1 on the same graph. Most of the time, your shaded regions will be outside of your 2 points for or compound inequalities. Most of the time. So or compound inequalities, you're just graphing the two graphs on the same graph. Okay? Are there any questions about and or compound inequalities as of right now? One thing I need to mention real quick. For our and compound inequalities, there's 2 ways to see them. You'll see them multiple ways on your assignment. You can see it with the 2 inequalities written with the word and between them. You may see it written like this as well, with the variable in the middle of your inequalities. Okay? You'll see it like this quite a bit. Anytime you see an inequality written like this, it'll always be and. Or will never be written like this. So anytime you see the variable in the middle between 2 inequality symbols, it'll always be and. Does that make sense? Or will always have the word or between it. Okay? Are we good? Okay, let's move on. Write each sentence as an inequality. Graph each inequality. Write each sentence as an inequality. Graph each inequality. So letter A number x is greater than negative 8 and less than or equal to 4. A number x is greater than negative 8 and less than or equal to 4. So, more than likely it's going to be some compound inequality, right? Does anyone want to take a shot at it right off the bat? Well, the first inequality, a number x is greater than negative 8. What would that look like? X is greater than negative 8. Everyone okay with it? And what type of compound inequality is it? And or? And less than or equal to 4. What would that look like? Do you think my variable changes at all? No, so what's my variable? X. Less than or equal to 4. There's my compound inequality. X is greater than negative 8, and x is less than or equal to 4. What's another way I could write this? The variable in the middle. How would I do that, though? Like that?
Yeah.
There you go. That's another way to write it. Either one of those will work. You can just write it with the word and between them if you want. Or you can write it with the variable in the middle. Does everyone see how this second way to write it represents both inequalities? For x is greater than negative 8, the alligator's eating the x, right? For this inequality, the alligator's still eating the x. Okay? Over here, the alligator's eating the 4. For this symbol, the alligator's also eating the 4. The x is just in between the two symbols now. Questions how we got that? Let's graph it now. So, how I like to graph is I like to just get our 2 points first, our 2 circles. What number is my first circle going to go on? Negative 8. Does everyone see that? First inequality involves the number negative 8, so that's where our first circle is going to go. And is it going to be open or closed? Open. Same rules apply. There's no line underneath my symbol. So I know it's going to be an open circle at negative 8. You okay with that? What number is my second circle going to go on? 4, because 4 is the number, a part of my second inequality. Open or closed circle on 4? Closed. It's got the line under it. It's or equal to. So I've got a closed circle on 4. Erase this one to give me a little bit of room here. For x is greater than negative 8, would I be shading to the left or right of negative 8? Right. To the right, correct? You don't necessarily have to draw this arrow if you want. I'm just trying to show you guys something. If you want to draw it, that's fine. X is less than or equal to 4, would I be shading to the left or right of that point? To the left. Everyone see that? For and compound inequalities, do I want the intersection of the two graphs or the union? The intersection, so I want where the two graphs' shaded regions are the same. Right? So if this one's being shaded to the right, this one's being shaded to the left, where's the overlap of our shaded regions? In the middle, between my 2 points. So I'm just shading right between my 2 points, and there's my graph. Any questions on that? Okay, let me ask you if some certain numbers are solutions here. Would negative 12 be a solution here?
No.
Why not? Say it again.
Is it because they're not in the training number?
Yeah, it's not in my shaded region. Also, if you're thinking about the inequalities, negative 12 is less than or equal to 4, right? But is negative 12 greater than negative 8? No. Remember, it's got to meet both inequalities for it to be a solution. Would positive 10 be a solution? No. It's not in my shaded region. 10 is greater than negative 8, but it's not less than or equal to 4. It doesn't meet both inequalities. Does that make sense? Would negative 2 be a solution here? Yeah, it meets both inequalities, right? Negative 2 is greater than negative 8. And negative 2 is also less than or equal to 4. It also is in my shaded region. Remember, our graph represents all the solutions for our inequalities. Would negative 8 be a solution here?
No.
Why not? Well, hold on. Why would negative 8 not be a solution? Yeah, it's not or equal to. It's got the open circle on it. So negative 8 is less than or equal to 4. But negative 8 is not greater than negative 8, is it? So it does not meet both conditions. It's also got the open circle on my graph. What about 4? Is 4 a solution? Yeah, it's got that closed circle. It meets both of my conditions. It's greater than negative 8, and it's less than or equal to 4. Does everyone understand our solutions for an and compound inequality? For a number to be a solution, it's got to meet both inequalities. Okay? We good with letter A? Okay, let's work on letter B. A number y is at most 0 or at least 2. Interesting. A number y is at most 0 or at least 2. Anyone want to take a shot at it? Or at least the first inequality. A number y is at most 0. Not quite. Yes, go ahead.
Less than or equal to?
There we go. If it's at most 0, can it be greater than 0? No, so it's got to be less than or equal to. So there's my first inequality. Is this going to be an and or compound inequality? Or. We see that or right there. So number y is at most 0, so y is less than or equal to 0, or at least 2. Does anyone want to take a shot at that second part of the inequality? Or at least 2. Sorry, say it again. I'm sorry. Y is greater than or equal to. If it's at least 2, can it be lower than 2? No, so it's got to be greater than or equal to. There's our compound inequality. Is there any other way to write an or compound inequality? Nope. So that'd be your answer. Okay? That'd be me writing my inequality, or my sentence as an inequality. Still want you to have at least 5 numbers on your graph when you're graphing. What number would my first circle go on? 0. Is it open or closed? Closed. It's a closed circle on 0. It's got that line underneath that inequality symbol. What number is my second circle going to go on? 2, because that's the number that's a part of my second inequality. Is it going to be open or closed? Closed. Okay, this is an or compound inequality. Am I wanting the union or the intersection of the two graphs? Union. So that just means I'm graphing the two graphs on the same graph. Okay? For y is less than or equal to 0, would that be shading to the left or right of 0? To the left. And since there's no stopping point out here, I do need to go ahead and put an arrow on my shaded region. Or y is greater than or equal to 2. Is that to the left or right of 2? What? To the right. So there's the graph of my or compound inequality. So, for a number to be a solution of this, it just needs to meet one of my inequalities, right? So, would negative 10... Would negative 10 be a solution here? Yep, it's in my one of my shaded regions. It meets the condition of y being less than or equal to 0, so it is a solution. Would positive 12 be a solution? Yep, it's in one of my shaded regions. It meets the condition y is greater than or equal to 2, so it is a solution. Is 0 a solution? Yep, it's got the open circle on it, or closed circle on it, my apologies. It meets the condition of y is less than or equal to 0. Is 2 a solution? Yep, closed circle on 2. Meets one of my inequalities. Is 1 a solution? No. 1 does not meet either inequality, does it? 1 is not less than or equal to 0. It's also not greater than or equal to 2. We also see that because it's not in our shaded region. We okay with that? Questions on example 1, A or B? Now let's solve some inequalities here. Solve some inequalities. Solve each inequality, graph each solution. So letter A, negative 4 is less than x minus 2 is less than 3. Is this an and or an or compound inequality? And. The variable is written just between two inequality symbols, right? The only compound inequality that can be written that way is and. So I automatically know it's and. Negative 4 is less than x minus 2 is less than 3. Usually, I'm using my inverse operations. Whatever I do to one side, I do to the other, correct? My goal here, since the variable is in the middle, I want to try to get the variable by itself in the middle. Does that make sense? So I'm using inverse operations to move stuff out of the middle away from x. I technically have three sides of my inequality now. The left, the middle, and the right. So whatever I do to the middle, I'm going to have to do to the left and the right. Does that make sense? So how would I get x by itself in the middle right here? Add 2 to all three sides. Whatever I do to the middle, I got to do to the left as well as the right. Because I technically have two inequalities here. Does that make sense? Negative 4 plus 2? Negative 2. I just have x left in the middle. What's 3 plus 2? 5. Keep in mind, anytime we multiply or divide both sides by a negative, I've got to flip my inequality symbols. Did I multiply or divide both sides by a negative? Or all three sides?
No.
No, so my symbols flip or stay? Stay. X is now by itself in the middle. There's my solution. Negative 2 is less than x is less than 5.
Teachers and students, please pardon this interruption. If I could have all NHS members to the big gym for group photos, thank you.
So, where's my first circle going to go? Negative 2. Is it open or closed? Open. Where's my second circle going to go? 5. Open or closed? Open. Okay, reading from the variable standpoint, this first inequality says x is greater than negative 2. Does everyone see that? X is greater than negative 2. So would that be to the left or right of negative 2?
Right.
To the right. Second one, x is less than 5. That's to the left or right of 5? Left. This is an and compound inequality. I want the intersection of the two graphs. So where are those two shaded regions going to overlap? In the middle of the 2 points. There's my graph. Questions on example 2a? Okay, letter B. Negative 3 is less than. Negative 2x plus 1 is less than or equal to 9. Once again, which type of inequality is it? And. It's got the variable between the two symbols. I know it's automatically and. Still trying to get the variable by itself in the middle here. What would be my first step to do that? Subtract 1 from all three sides. Whatever I do to the middle, I got to do to the left as well as the right. Negative 3 minus 1. Negative 4. We've got negative 2x in the middle. And what's 9 minus 1? 8. Symbols flip or stay? Stay. I did not multiply or divide all three sides by a negative, did I? Now, how would I get x by itself? Divide all three sides by negative 2. Negative 4 divided by negative 2. Positive 2. I've got x in the middle. 8 divided by negative 2. Negative 4. Symbols flip or stay? Flip. I divided all three sides by a negative, correct? So I've got to flip both of my inequality symbols. This less than turns to greater than. This less than or equal to turns to greater than or equal to. Everyone see that? Whenever we write and compound inequalities this way, we usually write the smallest number on the left side. So what's my smaller number, 2 or negative 4? Negative 4, right? I'm going to go ahead and flip it. So there's my solution. If you accidentally left it like this, I probably would not count it wrong, because that's still correct. Okay? We just generally write it this way in mathematics. Graphing it real quick. Open or close circle on negative 4. Closed. Open or close circle on 2. Open. And where would the overlap of the shaded regions be? If I'm greater than negative 4 and less than 2. X is greater than or equal to negative 4. That'd be to the right of negative 4. X is less than 2. That'd be to the left of 2. So where's the overlap? Middle, between the 2 points. Like I said, most of the time, it'll be in the middle. Questions on B here? I've got one more example for you and I'm done. Solve 3y minus 5 is less than negative 8, or 2y minus 1 is greater than 5. Graph the solution. Is this and or compound inequality? Or. It's got or between the two inequalities. I know it's or. To solve this compound inequality, I'm just solving each inequality individually. Okay? And then keeping the word or between them. Everyone okay with that? So the first inequality, 3y minus 5 is less than negative 8. What would be my first step to get y by itself? Add 5. Like I said, we're dealing with them individually. So I'm not going to add 5 to this side over here because we're dealing with them individually. Negative 8 plus 5. Negative 3. Symbol, flip, or stay. Stay. I'm going to bring my word or down. Second inequality, what would my first step be? What? My first step over here? Add 1 to both sides. 5 plus 1. 6. Symbol, flip, or stay. Stay. Does everyone see how we're doing this? Just solving each inequality individually, keeping the word or between them. First inequality, what would be my next step to get y by itself? Divide by 3. Negative 3 divided by 3. Negative 1, symbol, flip, or stay. Stay. Bring your word or down. Second inequality, next step. Divide by 2 on both sides. 6 divided by 2. 3, symbol, flip, or stay. Stay. Both y's are now by themselves. So here's my solution. Y is less than negative 1 or y is greater than 3. If you want to work out one at a time all the way through, you can do that. Just make sure at the end you get the word or back between them. If you don't have the word or, you'll get points taken off. You have to have either and or, in this case or, between your two inequality symbols, or between your two inequalities to make it a compound inequality. Open or close circle on -1. Open or close circle on 3. Open. It's or, so I want the union of the two graphs. I want the two graphs on the same graph. So y is less than -1. Would that be to the left or right of -1? Left. Y is greater than 3. Left or right of 3? Right. There's my graph. Any questions on solving either and or compound inequalities? It's everything we've been doing, right? It's just two inequalities put together with the word and or. Any last minute questions? Here's your assignment. Page 89, numbers 4 through 20 evens. I think that's 9 problems for you. Make sure you get this written down. Make sure you get the correct heading on your paper. Name, date, period, assignment, upper right-hand corner. Are there any questions about the notes before I end the recording?